Hey guys, Ben Pearson with Roaster Tracker, and today I want to talk to you guys about the exploration of the planet Venus. Now, Venus is one of the planets that has been known since antiquity. We've, tracked it for a number of years. It's really probably the easiest planet to see if you go look out in the morning or evening and you see a bright object that's kind of sort of close to the sun. Odds are pretty good that that's the planet Venus. It can be extraordinarily bright. It is really amazing. It's been confused for UFOs a number of times. The planet is the brightest object that we can actually see from Earth other than the sun and the moon. It can sometimes even cast shadows. It's a pretty neat little object. Anyways, we've known about it for a long time. Since we've had telescopes, we've known that the surface was pretty opaque because you can't see through the clouds. So we didn't see any kind of surface features or anything like that. What we did notice is that it has crescents, which is an indicator that it is closer to the sun than we are, which makes a lot of sense. They were able to predict the path and to observe it during some occultations, both of the sun and of other stars. And they were able to determine that it had, in fact, an atmosphere and that this atmosphere was pretty thick. They were able to measure some temperature guesses, really. And they didn't really know. They were kind of conflicted because some of them were coming out really, really hot. Some of them were coming out just a little bit warm, like a warm day on Earth as opposed to higher than the hottest oven that probably anyone who's watching this owns. Maybe some of you guys own some really, really fancy ovens. Who knows? Anyways, planet Venus is really, really hot. And the thought was, and turns out to be correct, that the higher parts of the atmosphere have a reasonable temperature. Lower parts are scorching hot. We were able to confirm some of this stuff once we started to get radars. We confirmed that the rotation rate is actually very, very slow. Venus was once thought to possibly be tidally locked to the sun. And the reason is similar to the reason for Venus. The same part of Venus tends to be pointed towards Earth when we are able to observe it. The reason why this happens with Mercury is because it has a 3-to-2 tidal resonance. Venus has a really curious resonance with Earth. It takes 8 Earth years for Venus to have 13 years, and there's all kinds of interesting things. It shows up in patterns in the sky. Even the Mayans knew about these patterns. The amount is off by 2 days, but it's still kind of a curious little resonance between the two different planets that has some effects over a long period of time. It has a retrograde rotation too, which it's a little tricky to explain, but it kind of goes backwards. We kind of rotate into the sun as we're going along. Venus rotates backwards, which is unusual. It's really the only planet that does this, although there are other objects in the solar system that do. We were able to confirm through these radar estimates the high temperature. And really, Venus is a pretty neat planet. It's really the closest planet to Earth in many, many respects, although because of its harsh temperature and pressure and the composition of its atmosphere, it would be very, very difficult to live on the surface. Turns out you could probably live in a fancy balloon and go flying around the surface. More on that later. Venus has had a number of spacecraft that have visited it. It is the most visited body other than Earth, the Moon, and possibly Mars, although Mars has only taken that title recently. The first spacecraft to visit it was the first spacecraft to visit another planet, period. It unfortunately stopped working on its way there, and that is the Venera 1 spacecraft. But it still managed to fly within 100,000 miles, so it gets some kind of an achievement. That's not nothing. Mariner 2 was the next object, the first one to actually record data. And because we knew that the atmosphere of Venus was so opaque, we didn't take really any color cameras or any kind of camera at all, but we were measuring the magnetic field, which you could also measure the magnetic field as you're going in towards it from the sun, and similar things like that. It was able to make some measurements of the atmosphere and confirm the temperature that we had. The theory, Mariner 5 had a ultraviolet photometer, so it was able to better measure inside of there. Kind of sort of a camera, but not really. But it was able to pave the way, and Mariner 10 actually had the first image of Venus from close up. It was done in the ultraviolet, which allowed us to peer through the clouds a little bit. It was the first image that was taken. It was in 1967. It's 5 years after the Mariner 2 spacecraft was the first one to actually work when it was close there. It's amazing how quickly, this was just less than 10 years after Sputnik, that we were doing all of this kind of exploration of the solar system. Pretty amazing stuff. Venera 3 was another Soviet mission. It was the first one to land on Venus, although it crash landed and it didn't produce any data, so it was still the first spacecraft to touch another planet, so that does get some credit, I suppose. And you'll see with the Soviet missions, they often send them in pairs with essentially the same spacecraft sent twice. This is done because the rockets were not reliable and the spacecraft were not reliable, but hey, if you double them up, then you actually have a chance. And they did have a more successful Venera 4 that was a copy of Venera 3. It was the first one to provide any kind of data on the surface, although it didn't make it to the land. It was able to provide data from the atmosphere and really confirm the temperature. It had a higher pressure than we expected. The pressure on Venus is just ginormous. It's hard to imagine how much pressure there is. It was able to look at the chemistry and realize that it's mostly carbon dioxide, but it was able to detect some of the other traces, and it's pretty neat. Venera 5 and 6 also continued along this path. They weren't working on hit the surface, but they gathered more data similar to Venera 4. Venera 7 was the first one to soft land on the planet. The Soviets were getting better at having them last longer, and so this one was able to work. It transmitted data. This happened in 1970, still well before we had a successful Mars landing. It did not have a camera because it wasn't really expected to land, but the Soviets had figured out how to do this, and so in 1972, they continued with the Venera 8. In 1975, they brought a orbiter and a lander combination in Venera 9, and the lander part actually successfully took an image of the surface. The orbiter was just collecting some of the same types of data that they had done previously, magnetic field, radar, that kind of stuff. Then came a couple of American missions that were launched that were related, and the names of these are kind of confusing. Their mission is most definitely called Pioneer Venus. And sometimes you'll hear them called the orbiter and multiprobe. Sometimes you'll hear them called 1 and 2. 1 is the orbiter, 2 is the multiprobe. I don't understand these things. But anyways, the orbiter was able to survive for a long time. It actually overlapped with Magellan, which was launched much later. It had a lot of instruments, spectrometers primarily, and radio science to try to figure out what the planet was made out of. It also served as a relay for the multiprobe. A multiprobe was a collection of 4 different probes, 3 of them which were pretty small and 1 of them which was big, and I think the bus of the spacecraft. They were just trying to collect atmospheric similar to the early Soviet missions, and 1 of them actually did manage to transmit on the surface, the only time that Americans have landed on the surface of Venus and transmitted data. And really, this was the only lander that we ever launched. So, towards Venus. It was kind of interesting. I don't know why we haven't explored it more. Venera 11 and 12 and 13 and 14 were all of a common design. They all had color cameras and they landed on the surface of the planet. But they have some curiosities that are worth digging into a little bit more. You see, Venera 11, the lens caps never released, so it never actually was able to take an image, but it still landed successfully. The same thing happened with Venera 12. With Venera 13 and 14, they had fixed the problem and those lens caps deployed. However, Venera 14 famously had a drill to go and detect them. They both had drills to go and see what the surface was made out of. And it just so happened that the lens cap hit exactly where the drill could reach. And so they measured the composition of the lens cap that came from Earth. I guess it could be a type of control, but where you only get one shot with these missions that only last for a little over an hour at best, it's pretty amazing. And the way that they worked actually is pretty cool. They pre-cooled the spacecraft to as cold as they could, and they had a coolant loop and all sorts of things to be able to maintain their cold temperature as long as possible. But it still took a lot of work to make it down to the surface. So hats off to the Soviets, man. It's pretty good stuff for the 70s to be able to pull that off. The next missions were also some Soviet missions, the Vega 1 and 2. These were really a flyby mission on their way to Halley's Comet, but they were able to drop off these balloons. And I've seen a I don't know if it was an engineering prototype or something of these in the Smithsonian. There are these little landers that are like this big as the instrument package. You have a balloon that's pretty large, but not really that much. They only weighed a couple 100 pounds, and it's one of the lightest payloads that's ever been launched. I think it could almost launch on an Electron rocket towards Venus, which is pretty cool. A balloon going around Venus would be amazing. And the way that the system is set up, the pressure and such, if you're about 60 kilometers high off the surface, you could put in basically what we're breathing here on Earth and to a balloon, and that balloon would float. And so you could live inside of there, and it would work pretty reasonably well. You just have to make sure you don't have any leaks, because that would be a really bad day. Then the next mission, we had Venera 15 and 16 that were in polar orbit. They were kind of similar to the Pioneer Venus orbiter. They did do some radar imaging and some spectrometry work. Spectroscopy. There we go. There's the right word. Looking at the atmosphere and trying to determine some things. The best image of Venus that we have came from the spacecraft Magellan. Magellan is a really interesting mission. It was really just trying to take a spacecraft and make it as cheap as possible. And so we knew that we wanted to use a radar to look down into the surface of Venus. We also know that we needed to have a high-powered communication system to be able to send the data back. It turns out that the two can be the same instrument. And so they had a combination radar and spacecraft tracking or communication antenna. And so it had this elliptical orbit because it had to be. We didn't have aerobraking at those times, and it just would have taken a lot of fuel, and it was trying to be on the cheap. So what would happen is when it was doing a close approach of Venus, it would point its radar dish down and do radar imaging, and then it would save all the data and then point it back towards Earth and send it back, and it would rinse and repeat this. And slowly, because Venus was rotating so slowly, they were able to get a pretty good map of the surface of Venus, something to the order of 100-meter resolution. Pretty neat. And this overlaps somewhat with the Pioneer Venus orbiter. I think it may have also been working a little bit when the only two modern missions, which are Venus Express and Atkasuki, were launched. Venus Express was an ESA mission. Atkasuki was a Japanese mission, which is probably why I'm horribly mispronouncing it. My apologies. These two missions were kind of complementary. They were really trying to observe the weather of the planet Venus and look inside of the clouds. So they have a number of cameras that have some specific wavelengths that can look down to the surface and look through these clouds. They're able to do some pretty neat stuff. Atkasuki is still there. It took a while to get there. They launched it to Venus, and then when it came time for it to enter into the orbit, the main thruster stopped working. So they were able to figure out a backup mission that would allow it to get there. In addition to all of this, there have been a number of flybys of the planet Venus on its way to somewhere else. It turns out that Venus is a very convenient object to do these. And the first one to demonstrate this, and the first flyby ever actually, was Mariner 10, which we talked about in our Mercury series. It was able to do, I think, 3 flybys of Venus and image the surface, do some reasonably well stuff, which allowed it to go to the planet Mercury. We have also had the Messenger spacecraft that the Americans sent recently to Mercury, and Bepi Colombo that is on its way there now, that have also been doing flybys of Venus periodically. It also turns out that it is good to get to the outer solar systems. There is a launch trajectory that is known as the Vega, Venus Earth Gravity Assist. And sometimes there'll be an Vega, you'll do an Earth flyby first, which I think is probably going to be in the works for some future missions. Maybe Cassini did that, I don't remember. It makes the launch trajectory a little bit easier to calculate, and since spacecraft are starting to work for a long time, we don't worry about it as much, having the extra couple of years to make the mission much easier to design. So this was done by Galileo and Cassini on their way to Jupiter, and then Cassini hit it to Saturn. This was done to make it so that they could have a much lower velocity when they were approaching the planet so that they could actually successfully orbit, and it worked out pretty neat. It also saved a lot on the spacecraft launch mass. And in particular with Galileo, the Venus flyby was essential because it was flew on the space shuttle, and the original plan was to have a hydrogen booster on the spacecraft, but they could not actually do that because it was deemed unsafe after the Challenger incident that blew up. So they switched it to a solid rocket motor, and that had enough thrust to do the Venus flyby. So it worked out pretty neat. It also works pretty good if you're wanting to get close to the sun, and that is what Parker Solar Probe and also the Solar Orbiter are using it for. And so they're doing a number of flybys in order for them to get closer to the sun and to observe it better. Overall, though, Venus has been very richly explored. It is a very interesting planet, and historically, it had a lot of missions. It doesn't have a lot of modern ones, although there are a number of ones that are in development. Rocket Lab has one that they're trying to do for private enterprise. There are 2 that were Discovery class missions from the United States that have been funded, so they'll eventually launch in less than 10 years, we'll say. And there are some other interesting ones. There's VAMP, that's a new balloon that could go explore it that is being built. I don't know how they would get that one there. And there are some other ones as well that are pretty neat. Thank you guys so much for joining me. Let me know whatever questions or comments you guys have. And thanks for sticking around. Thanks to my supporters. You guys are amazing. And to those who subscribe and like and support me on Patreon, really, I'm so humbled by all of the support I get from you guys. Thanks for everything, and until next time, keep on tracking. Take care, guys.